Hello everyone. Today we're going to start the STL algorithm walkthrough. Many people has used STL containers a lot, especially the vector, but they rarely use STL algorithms. The main reason is they are not aware of what kind of algorithms are there and they are not familiar how to use them. But the fact is you should be using STL algorithm and you should be using them a lot. So the main purpose of this walkthrough is to give you some impression of what kind of algorithms exist so that later on when you are facing a similar problem, it may pop up in your mind saying, hey, I remember there's something similar in STL algorithms. Let me look up. Then you can look it up and start using it. During the walkthrough, I'll be using C++11 lambda function a lot. If you are not familiar with lambda function, don't be scared. Lambda function is just a function without a name. And here is an example of lambda function. It takes an integer parameter x and return if x is less than 10. So this simple lambda function is the same as this regular function. And following are the variables that I'll be using: vector of int, vec, and vec2, iterators, iter and iter2, and a pair of iterators, pair of iter. Today we'll be walking through the non-modifying algorithms, which includes count, min and max, compare, linear search, and the checking of certain attributes. Note that some of the algorithms only exist in C++11, but if you're using the old C++, you can always find the algorithms in either TR1 or Boost. Now let's get started. First, counting. The count function counts the number of items that equal to 69 in this data range. And since there are two 69s in vec, so the result is 2. As we mentioned, the algorithm function takes data through iterators. So in this case, it's using this pair of iterators to specify the range of data that the algorithm will be working on. So if I use vec.begin plus 2, then the range of data is this range. The first two are excluded. And if I use vec.end minus 1, then the range of data is from 90 to 55. The COUNTIF is similar to count, except that it allows me to define the condition for the items to be counted. So in this case, I'm counting all the items that's less than 10, and there are 3 of them, so the result is 3. This is the typical structure of algorithm function. It uses the function name to indicate the algorithm, how the data will be walked through, and iterators to indicate the data, and a function to specify the operation that will be applied on the data. So algorithm, data, and operation. You'll see this kind of pattern throughout the different algorithm functions. Another thing to note is the count function only allows me to specify a number. That is because it's using the default comparison operation of equal. I can do the same thing with the COUNTIF. This will also count the number of items that equal to 69. Number 2, min and max. Max element returns the first biggest element in this data range. And since in this data range the biggest element is 90, and there are two 90s, so the max element will return the first match, the first 90. Most of the search algorithm returns the first element that matches, but some of them will return the last match. Max element also has an overload function that allows me to provide my own version of comparison function to determine who is bigger and who is smaller. And in this case, I'm only looking at the last digit of the elements. So this function will return the first element whose last digit is the biggest. So it will return 9. The first version of the max element uses the default comparison function of less than. Most of the algorithm functions provide two forms: a simplified form that uses certain default comparison function or default computation operation, and a generalized form which allows you to provide your own version of the operation. Sometimes the simplified form and the generalized form has the same function name, like the case of max element, and sometimes they have different name, like the case of count and countif. And during the walkthrough, for the purpose of simplification, sometimes I only mention one form of the algorithm. Min element finds the first smallest element in this data range, and it will find 7. Min element also has a generalized form with the same name. Min max element returns a pair of iterator which points to the first smallest element and the last biggest element. Note the first smallest element is the same result as the min element would return, but the last biggest element is not the same result as the max element would return, because max element returns the first biggest element. And here I only show you a generalized form of min-max element. It also has a simplified form which uses the default comparison function of less than. Number 3, linear searching. You should use linear search only when the data is not sorted. If the data is sorted, use binary search for faster searching. Linear search returns the first item that matches certain condition. So the find finds the first item that's equal to 55. Find if finds the first item that's bigger than 80. Find if not finds the first item that's not bigger than 80. Search n finds consecutive n items that match certain condition. In this case, it finds consecutive 2 items that's equal to 69. And search n has a generalized form with the same name. Search subrange. First, I define a subrange data pattern. Then I use the function search to find the first subrange that matches this pattern. I can use find end to find the last subrange that matches this pattern. And they both have a generalized form of the same name, search and find end. It's kind of weird that these two functions complement each other, but they have very different names. Search any of. First, I define the items to be searched. Then I use the function find first of to find the first item in the vec that matches any one of the items. And this is the generalized form of find first of, which checks the condition of x equal to y times of 4. Search adjacent. Adjacent find finds the first 2 adjacent items that are the same, and it also has a generalized form. Number 4, compare ranges. Function equal checks if vec and vec2 are the same. Is permutation checks if vec2 is a permutation of vec. Mismatch finds the place where vec and vec2 are different. It returns a pair of iterator which points to the place of difference. Lexicographical compare does a one-by-one comparison with certain less than operation, and it does the comparison from beginning to the end until the first item of difference is found, and then it decides which one is less by comparing the item of difference. So 1, 2, 3, 5 is less than 1, 2, 4, 5 because the first item of difference is 3 and 4, and 3 is less than 4. 1, 2 is less than 1, 2, 3 because 1, 2 has one less item. That is why it is less. All of the comparing algorithms have generalized form of the same name. Number 5. Check attributes. Is sorted. Check if this range of data is sorted. Is sorted until will find the first place where the data is no longer sorted. They both have generalized form of the same name. Is partition. Check if the data is partitioned into two groups according to this condition. Is heap. Check if the data is a valid heap. Is heap until. Check where the data is no longer being part of a heap. And they both have generalized forms of the same names. The last three functions are actually pretty useful. All of. Check if all of the data matches this condition. Or any of. Check if any one of the data matches the condition. And none of. Check if none of the data matches the condition of larger than 80. That's all for today. Thank you for watching. Feel free to subscribe to my channel so when I post a new video, you will be updated. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.